Okay guys, this is Student Notes 11.3, Area of Sectors. Well, before we can find an area of a sector, you have to know what a sector is. It's really simple. A sector, I'm going to write it right here, the definition. A sector is a region inside a circle bounded by two radii. Okay. For example, it's basically just like a piece of pie. Okay. So here's our whole piece of pie, and a sector is just a piece of it. So from the center, you have two radii, one there, and this little part is the sector. So it's just basically a part of the whole circle. That's all a sector is. Okay, so let's look at this top section here. With a partner, well, we're not going to do a partner right now. We're going to do it all together. Find the area of the shaded region of each of the circles below. Leave the answer in terms of pi. Okay, so this is half of a pie that's shaded. So this sector that we have right here is half. Okay? Well, we can find the area of the whole circle because we know that the area of a circle is just pi r squared. And it tells us that the radius of this circle is 12. So the area of this circle would just be pi times 12 squared, which is 144 pi. 144 pi. But we're just looking for half of the whole circle. So all we're going to do is divide it by 2 to find the area that is the shaded region. So 144 pi divided by 2 is just 72 pi centimeters squared. Okay. What about this guy? Well, obviously this is a 90-degree angle, and we know that an entire circle is 360 degrees, and there are 4 right angles in a circle. So this guy right here is 1/4 of the whole circle. Like this one over here was 1/2. Okay, so again, we know that the area is still the radius of 12, so the area is still the same. 144 pi is the area of the whole circle. But to find just the area of this section here, 1/4 of the whole circle, we would just cut it or divide it by 4. 144 divided by 4 is just 36 pi centimeters squared. And the last one right here, 120 degrees. Well, we know that if we take 360 and divide it by 120, we get 3. So this is 1/3 of the whole circle. Again, our radius is 12, so we have 144 pi. And this is 1/3 of the whole circle, so we're going to divide it by 3. 144 divided by 3 is 48. So the area of just the shaded region here is 48 pi centimeters squared. Okay, so what did we learn from this? How can we actually find the area of a sector if it's not just a pretty fraction, like a half of something, a fourth of something, a third of something? Well, we set up a proportion. It's really actually super easy. What we did here is we found out that 120 degrees is 1/3 of 360. 90 degrees is a fourth of 360. 180 degrees is half of 360. So what we do is we take the measure of our angle, or the measure of our arc, and divide it by 360, and we make that equal to the area of our sector, divided by the area of the whole circle, which is pi r squared, because that's the formula for the area of a circle. So our measure of our arc divided by 360 equals the area of our sector over pi r squared. So it's just a proportion, kind of like a percent proportion, but instead of a percent, we're doing degrees out of 360. Okay, so let's try one. Example 1, find the area of the sector. So we're looking for this value here. Give your answer in terms of pi. Okay, well, remember it's the measure of the arc in degrees over 360 degrees is equal to the area of the sector. I'm just going to say area of sector here over pi r squared. Okay. From now on, you'll see me call area of sector just A. Okay, so we're looking for A. Well, what is the measure of our arc that we have here? The shaded region here is our sector. The arc is 160 degrees. So 160 degrees divided by 360 is equal to, well, we don't know the area of our sector. That's what we're looking for. So I'm going to label that A divided by pi r squared. Okay, well, let's find pi r squared. We have pi times, our radius is actually 6. So times 6 squared. And 6 squared is 36. So the pi r squared, or the area of our circle, is 36 pi. Okay? Solve our proportion by cross multiplying. A times 360 is 360A. 160 times 36 is 5,760. 5,760, and then the pi, because it's the 36 has pi on it. And then, to solve for A, divide by 360 to both sides. So 5,760 divided by 360 is equal to 16. So area is equal to 16, and there's also a pi, so let's not forget that. 16 pi inches squared. So the area of the whole circle is 36 pi, but the area of just the shaded region is 16 pi. Okay, we're going to save example 2 for class. Turn to the next page, and we're actually also going to save example 3 for class. So I want us to look down on example number 4. Before we decide how to do example 4, we're going to talk about the definition of a segment, which is right here on the left-hand side. Okay, so far you've learned what a sector is. A sector is just a region of our circle, the shaded region of our circle. Okay, a segment is actually, I'm going to show you a picture of it before I actually write it out for you. A segment, here's another sector that I'm drawing in purple. Okay, a segment, though, is if we draw a chord from each endpoint of our sector, then it leaves this tiny little area right here. It kind of looks like pizza crust or the crust of pie. The crust right there is called the segment. Okay, so this right here is a segment. The whole thing is the sector. Okay, so a segment is a region inside a circle bounded by a chord and an arc. Okay. So this segment right here is bounded by the chord, which ran across here, and the arc, which is the outside. So all that blue on the inside is the segment. Okay, so how are we going to find the area of the segment? Okay, it's actually not very hard. First, what you do is you find the area of the whole sector, which is what we've been doing. On the previous page, the area of a sector is just this. So we're finding the area of the piece of pie. We're doing m over 360 m over 360 is equal to area of the sector over pi r squared. Okay, so let's look over here. So right now, the sector, I'm going to go ahead and outline it. The sector is this giant piece of pie. Okay? It's sector RST, the whole thing. Okay, so let's follow this. The measure of our arc, how many degrees is it? Well, right here we have a right angle. So the measure of our arc is also 90 degrees. So 90 degrees divided by 360 is equal to, we don't know the area of our sector, divided by pi r squared. Well, our radius is 4. So pi times 4 squared. 4 squared is 16 pi. Okay? So let's go ahead and cross multiply. So 360 times A is 360A. And 90 times 16 pi is 1,440 pi. And then we divide by 360. All right? So the area of our sector is 1,440 divided by 360, 4. Now, a lot easier way to have done this was to just see that, okay, our sector is 1/4 of the whole circle. So all we really needed to do in this case was take 16 pi, because that's the area of our circle, and divide it by 4. Because this is 1/4 of the whole thing, which would give us 4 pi. Okay, so that's the area of our sector. Find the area of the triangle RST. Okay, so I'm going to erase some of the markings I've made on here. Okay, triangle RST is everything inside of the sector that's not the green part. So I just highlighted it in yellow right there. So if we were really looking at this triangle, it's just a right triangle. It looks like this. Okay, and this is 4. That's one of the radii is 4. And guess what? ST is also a radii, so that is also 4. So we have a base and a height of 4. Well, to find area of a triangle, it's just base times height divided by 2. So the base of the triangle is 4. The height of the triangle is 4. 4 times 4 is 16. Divided by 2 is 8. So the area of the triangle is 8. So really what we're doing here to find the area of the segment is just to take the big which is the area of the sector, and subtract the small, which is the area of the triangle. The big subtract the triangle will leave us with the crust, which is our segment. So the area of the sector is 4 pi from up here, minus the area of our triangle is 8. And we can't simplify that anymore because this has a pi and this does not. So the area of the segment is just 4 pi minus 8 meters squared. Okay, we're going to save example 5 for class, so I will see you guys then.